How are you doing today? I hope your day is going well. Hopefully it's a little sunnier than it is right now. It's kind of gloomy out right here, but all right. So 11.4, we're going to be talking about area of regular polygons and composite figures. This is really going to be challenging us to bring in our skills using trig functions and finding missing measurements using all of that fantastic material we've learned. So let's try this. Here we go. All right. So a regular polygon. So I want you to think about a regular polygon, meaning all sides are congruent, because that's what it is, okay? The center of the polygon is the center of a circumscribed circle. So a circumscribed circle goes around the outside of it, okay? Just like the one that it shows here. The radius of a regular polygon is the radius of a circle. So that's AP. So AP in this picture is considered, oops, right here. All right. And then the apothem, this is a new word. So I want you to give it some thought here. The apothem is a segment drawn from the center perpendicular to a side. This is an apothem. Okay. And so that's going to be super helpful when we're trying to utilize right triangles and working through that. So, and then the central angle of a regular polygon has its vertex at the center of the polygon, and its sides, it passes through consecutive vertices. All right. So let's take a look and see what we get to do with all of this work. So let's put this into action. So in this figure, let's first actually, before we put it in action, make sure we understand this. So PQRST is inscribed in circle X. We're going to identify the center, the radius, the apothem, and the central angle. Okay, so here we go. Good times. The center is X. The radius is XQ. The apothem is XN. Central angle. We need to figure out what that central angle is. This is a pentagon. And there are 360 degrees in the central angles of a pentagon. So we're going to take 360 degrees divided by 5, and that's going to give us the central angle of the polygon. So 360 divided by 5 is 72 degrees. The central angle, I think I should have listed it as QXR, and I didn't do that, but I should do that. Okay. So we're relying heavily on skills that we've already worked with. The apothem is new, so that's one we want to pay attention to. But in terms of central angles and measure of central angles, those are skills we've worked through. They just get to come back. In this figure, we want to also find the measure of the central angle. When I look at this figure, it tells me it's a hexagon. It tells me there are 6 sides. So the measure of the central angle, so the measurement of angle CGD is equal to 360 divided by 6, because there's 6 sides, so 60 degrees. CGD. All right, now this is a brand new formula for you, okay? This is the area of any regular polygon. So any polygon that has all sides the exact same, this is the formula we're going to use, okay? I think this formula right here makes the most sense. It's 1/2, okay, it's 1/2 the apothem times the perimeter. 1/2 times the apothem times the perimeter. What this tells us right here is the number of sides times the side length. So I just think 1/2 times the apothem times the perimeter makes a whole lot of sense. Look at that. The sun's starting to come out. Just as I was telling you, the sun wasn't out. All right, so let's put this to use. Find the area of a regular hexagon. All right. So area is equal to 1/2 times the apothem times the perimeter. What I know in this triangle is that it's a hexagon. So that means there's 6 sides, and each side is 5 meters. So the perimeter is 30 meters. Now what's left to determine is what what this apothem equals right here. I got to figure out that height. So what I'm going to do is pull that out like this. And so this measurement is 2.5. I need to find x. Now what I know is this is a 6-sided figure. So there are 6 central angles that are each 60 degrees. So QPR is 60 degrees. That makes QPS, so here's Q, here's P, here's S, that makes that angle 30 degrees. Well, now what I have is a 30, 60, 90 triangle, and I know the relationship between those sides. Opposite 30 is x, opposite 60 is x square roots of 3, and opposite the right angle is 2x. So the apothem of this figure is 2.5 square roots of 3. So the area is equal to 1/2 times the apothem, which is 2.5 square roots of 3, times the perimeter, which is 30. 1/2 is equal to 2.5 square roots of 3 times 30. So let's figure out what that is. 30 times 0.5 times 2.5. So the area is going to be 2.5 times 15 times the square root of 3. Let's so the nearest hundredth, the area is going to be 64.95 meters squared. All right. When it says to the nearest hundredth, that tells me it's okay to type in the square root of 3 in my calculator, and I don't have to have it in simplest radical form. Okay. Let's try it again. Okay. You have all the information that you need. We just have to know how to pull that all together. It's like in the cupboard, you have all the ingredients that you need to make your oatmeal cookies. You just have to know which ingredients to pull to mix it together to make it work. That's what we're talking about here. So we're going to find the area of the regular pentagon. And so we've got 1/2 times the apothem times the perimeter. Well, all I know is that CB is 9. So I need to figure out this measurement and that measurement so I can figure it out. So let me look. In this triangle, this is 9. It's a pentagon, so 360 divided by 5 is 72. So the central angle is 72, which makes this 36. But I need to figure out these two measurements. 36 isn't a special kind of triangle, so I'm going to have to use trig functions. So SOHCAHTOA, right? So the sine of 36 is equal to opposite over hypotenuse. And the cosine of 36 is equal to y over 9. So now that's going to help me figure out those measurements. So I'm going to take the sine of 36 times 9. So this measurement right here is 5.29. Okay, 5.29. And then the cosine of 36 times 9, and this is y, is going to be 7.28. So now what I need to do is I have the apothem and I can figure out the perimeter. So I'm using my trig functions from a few chapters ago. So if this distance is 5.29, and if I double it, I get 10.58, and there's 5 sides. So 10.58 times 5, my perimeter is 52.9. My apothem is That wasn't 7 point. Let me check this again. I don't think 7 point. I think it was 7 point something. Let me double checking something here. 36 times 9. This should have been 7.28, not 4. Here we go. So 7.28 times 1/2. Okay. So 0.5 times 7.28 times 52.9. The area is equal to 192.56 centimeters squared. Okay, so when we look at this, it's pulling in a lot of those pieces, and you're going to do great. And if you need help, I can guide you in the right direction. Will I answer the question for you? Absolutely not. I will help guide you in the right direction, because the more thinking you do, or the more thinking I do, the less you do. So I want you doing more of that thinking. Okay. So a composite figure is one that can be separated into different pieces. We've talked about that. You've talked about that before, but it's been a while. And you can really divide these up however you want to. I mean, it really doesn't matter a lot to me. I mean, this one here could even be divided up into a trapezoid and 2 semicircles. I mean, it really comes down to your comfortability level. So do it how it works for you, how your brain conceptualizes it. That's what I want you to do. Okay. So we want to figure out the area of this pool. Well, I have 2 semicircles. So together that's 1 circle. So I can take pi times radius squared. And then you can either do a trapezoid, or you can do a rectangle and a triangle. If I do a trapezoid, I'm going to add 1/2 the height times the sum of the 2 bases, 16 plus 31, and put that together. So 64 pi plus, let's see what 16 times 47 plus 752 plus 64 times 3.14. 952.96 feet squared. Okay. How are you doing? It's a lot, but you totally can do it. And I know in a video, I tend to go faster than I do in class because I want to make sure we get everything in. Okay. Here's our last one. We want to find the area of this figure round to the nearest hundredth. Okay. So what I see is I have 2 triangles. Base times height divided by 2 is 20. Base times height divided by 2 is 20. 18 times 8 is going to be 144. So sometimes I like to just put my areas in each of those parts. And then the semicircle is going to be 9 squared plus, or times pi. So, oh, wait. Yeah, 9 squared times pi. And I'm going to add all of these together. So 144 plus 20 plus 20 plus 81 times 3.14. So 438.34 feet squared. And that is composite figures. Okay. So again, we're pulling all of this knowledge together that we've already possessed, and we're just trying to puzzle it together and make it work. So let me know if you've got any questions. If not, I'll catch you real soon. Take care. Bye-bye.